we'll do this one together. What we're going to do is we're going to multiply this fraction by the same thing but the conjugate. And if we multiply the bottom of the fraction and the top of the fraction at the same time, technically we're multiplying by 1. We're not changing what it equals to, just changing what it looks like. Put the bottom in brackets like this, and this one in brackets because it has 2 terms. On the top, when you multiply that through and you distribute the 2, and on the bottom, you can either go right away to the shortcut being the fact that if you know that x plus y times x minus y is x squared minus y squared, that's basically what I have here. And so when I multiply them together on the bottom, I will get x plus 3 and minus 2 and the minus plus 2 would be minus 4. That would be the shortcut for doing it. If you want to, you can use your arrows and multiply everything out. But the ones on the outside and the ones on the inside are going to cancel out. And now we can simplify this. X plus 3 minus 4 would just be x minus 1. Want to check if you were How did you do on the first one? Other than that, it was good. So here we're rationalizing the numerator. Here we'd have to. Now, for most of the things that we're going to be doing, once you've rationalized the numerator like we did here, at this point, actually multiplying the bottom out won't make sense because I don't know if you can see that we have a common factor here. And these two would simplify. And just because it's exciting and what we're leading towards, what a question like this and what we did right now, and the reason we did it, is because we're going to look at questions that start off very similar to this, with the word limit in front. And what the word limit in front says is it says, what is this equal to when x gets really close to 16? And the reason x can't be 16 is because if x were 16, 16 minus 16 on the bottom would be 0, and dividing by 0 is bad. So what we want to find out is when this gets really close to 16, what does this answer look like? Now, we can't solve it right now the way that it looks. But what we did over here with rationalizing the numerator, we basically said that these two expressions are equivalent. And so this question is the same as what happens when x gets really close to 16 of this? And in that one, what happens when you plug in 16 for x? It's not bad, right? If I plug in 16 where the x is, I'd have 1 over the square root of 16 plus 4. The square root of 16 is just 4. So it would equal 1 over 8. And that would be the answer. And if you did go to your calculator and put something in really, really close to 16, like 15.99, you would find out that the answer would be really, really close to 1/8. And if you did 15.99999999999, depending on how many times you want to hit the 9 on your calculator, you would get even closer to 1/8. And what this technique will tell us is that when at infinity, if you got as close to 16 as theoretically possible, it would equal 1/8. All done? We'll just add your name and then we'll get your number after. I'll get it later. So first question, when you multiply the top out, were you able to get the x cubed minus 1? Because when I would multiply this times this, well, the x times the x, that gives me the x squared. And a root x times a root x just gives me an x. And then when I put those together, I would get an x cubed. So I get that final expression right now with the x cubed minus 1 over the square root x root x plus 1, x minus 1. Can you see that that can be simplified? Because we have a difference of cubes on the top. You could factor out an x minus 1, leaving us with an x squared, a y squared, and a plus xy. And those factor and simplify. Oops, I don't. No, it should be just plus x plus 1 squared. Sorry. It must be 1. I just was thinking the formula. Yes. Because if I would go this and this one, I have a plus x, and this one are already a minus x with the minus 1 here. And if we look back at the formulas for those ones, whenever it's a minus, the minus is here and the plus would be here. Whenever it's a positive, the positive's here and the negative's there. And this one too, the limit question would be what happens when x gets close to 1? The original expression, we have a problem because you divide by 0. But in the final expression, you could plug in 1 here, and the top would equal 3, and the bottom would equal 2. And as x gets really close to 1, that would get really close to 3/2.